Hi again. One of the questions I have received a couple of times so far is how Aegis can fit into a CI/CD pipeline. Or in other words, if an operator, I mean a human operator, wants to store some secrets to be dispatched to workloads and they want to use Aegis for this, but they don't want those secrets to be kept in source control, what can they do? Well, there are several approaches to this, and in this video I will suggest a solution with the least amount of moving parts, and it's relatively easier to implement. Before I begin, I'll assume you are comfortable with Aegis concepts and also PGP as an encryption decryption algorithm/tool. If you want a refresher in either of these technologies, you can check out the links that you see here. And here's the sequence of actions that I will try to emulate in this quick demo. First, I'll assume that we have a human operator and I'll be wearing the hat of that human operator figuratively. And that person can be like a DevOps person or a system administrator who has a set of secrets to be encrypted and assigned to a workload. This is our operator and this workload needs to know about the secret down here. So how can we securely provide the secret to the workload? Well, in this scenario, we assume that the CI/CD actor, which can be Jenkins, Circle CI, AWS code pipeline, or something similar, but we assume that the CI/CD actor has an asymmetric private-public key pair that it can lend the public key to us. And as an operator, we know the pipeline's public key, but the private key, of course, is within the pipeline and it is kept secret and it's secured. So what we do is we are going to encrypt the secret with the CI/CD pipeline's public key. Since the public key is by definition public, there is no security risk of it. There is no risk of it being leaked because it's public anyway. And then we'll send a pull request adding the encrypted secret to the ops Git repository. And the CI/CD system will be watching this repository. And when it sees the new secret, it decrypts the secret directly and sends a register this secret to this workload please command to Aegis Sentinel. But the important thing to note is while decrypting the secret, it is never saved to disk and everything is kept in memory. And for this, we are going to use Linux primitives and we are going to stream the file to the bash command prompt by using Linux pipes, which is a fancy way of saying that we'll be using the pipe operator. And after Aegis Sentinel registers the secret to Aegis Safe, the workload will eventually query Aegis Safe and get its secret. There are different ways for the workload to get its secret, and we have example use cases in Aegis repository that you can browse and check out, such as you can use Aegis SDK or a sidecar, or you can use an init container scenario. And in this video, I'm going to demonstrate the init container use case as it is the easiest way to demo this kind of a scenario. However, in a production setup, when it's possible, I recommend fetching secrets using the Aegis SDK instead of an init container or a sidecar, because the SDK gives more flexibility and it provides an advanced API that is not directly provided by the sidecar or the init container approaches. So if you want some fine-tuned flexibility, then the SDK is the way to go. But if you want some convenience, then you can use sidecar or the init container approach. So that's the overall workflow. So let's see all of it in action. So this is my initial system. I don't have any workload in my default namespace, and I have Spire and Aegis installed and up and running in their corresponding namespaces. I'm going to deploy the example use case of a workload that uses an init container, as I said before, and I'll do this by doing a make example init deploy local. If you want to learn more about these commands, you can check out the video linked here. But after running this command, my example use case will be deployed on my cluster. When I check the status of this pod, you can see that it is pending because the the pod has an init container waiting for a secret to be assigned to itself before it allows the main container to execute. So let's register a secret and see if this init status changes. But before that, I want to split the screen so that we can watch this pod and see the changes in real time. And actually, let me move this down here. So my demo workload pod is down below. I'll be watching it by kubectl get pow pod name -- watch. And in the top terminal, I'll be pushing the secret to this workload. So when I cd into the workload using init container example folder, I have this register.sh and this encrypt.sh. The register.sh is a command that finds the sentinel pod in the system and then pushes a secret to our demo workload. But the problem is I don't want these secrets to be source controlled in plain text in my Git repo, because it's a terrible security practice in the first place, and it will raise lots of red alerts by the InfoSec teams and all. That's why I want these secrets to be out of the Git repository, or at the very least kept encrypted in the source control if I want to keep them in the source control. So I'm going to encrypt this file with the public key of the CI/CD pipeline and then save the encrypted file to a common Git repository. Here's how the encryption is done. There, I'm assuming this key is the GPG public key of the CI/CD server, and once encrypted, the only entity that can decrypt this encrypted file will be the CI/CD server itself. So when I run this encrypt.sh, it generates the register sh.gpg, and when I look into the contents of the file, it will not make any sense because it's a garbled encrypted text. That's the whole point. It should be encrypted. Now let's assume that we pushed this encrypted file to our repository and the CI pipeline detected the change and downloaded it to trigger a runner. And this run sh, for the sake of our argument, is that runner. So let's see what it has in it. Well, it's a one-liner. We decrypt the file using the CI/CD pipeline's private key this time, and without even saving it to disk, we directly stream it into bash with the pipe operator, like I said in the beginning of this talk. So bash will take care of the input streaming and piping and execute the contents of the file without even saving it to disk. And that execution will trigger the rest of the chain of events in our sequence diagram, and this will eventually result in the secret to reaching our workload. So let's execute run sh, and it will ask for a password for an added layer of security. And when I provide the password, the script will be decrypted and executed, and almost immediately you'll see that the pod down below start initializing and then running. And when we tail the logs of the pods, you can see that it has happily received its secrets, which also ends this demo. So in a nutshell, that's how you can store an encrypted file in a repository, let your CI pipeline decrypt it, and then use it to register a secret to a workload. Hope this was informative for you, and I'll see you in the upcoming Aegis videos.